Hey guys, Rudi back with the second part of the week 4 tutorial solution for CSSE1001 and 7030. If you haven't checked out the first part, definitely check that out. Or I guess if you're only here for the second part of the tutorial, then stick around for this part. But yeah, I'll chuck a link to the first part in the description if I remember. So the last thing I remember is we were doing this print codons section here, right? We just done our loop. We were printing our codons each time, right? But I'm actually gonna have a look at this challenge here. And it raises a sort of good point here, right? In general, if we're doing a function that performs some sort of logical task, right, some sort of processing, we don't really want to generally output from within that function, right? When I say output, I mean we don't generally just want this to print, okay? Because let's say I run this function, and later down the track, I actually want to know what all my codons are. Well, I don't really get anything back from this, right? We're not returning anything useful. We just printed stuff out on the screen. So generally, a much better approach is to have a function like this codons function actually give you back something useful. So like say a breakdown of all the codons. And then, if you want to print that, then later on you can print that yourself, right? So we're actually going to write this function here, this generate codons function, that returns a list containing each of the codons of the sequence DNA. Okay, so it's pretty much going to be identical, except, well, let's just rewrite this. Generate codons. Okay, so now instead of printing here, we want to be building up a list so that we can return a list at the end. Okay, well, let's set up our codons list. So before we do anything, we're going to start off with a blank list and we're going to build on it, right? The same way we start off with a blank string before and we build on it. And so instead of printing each time, we want to add this guy into our list. Okay, now how do we add to a list? Well, we take our list, codons, and we use the .append method. Okay, now what this does is this just sticks this element on the end of our list. Okay, and then, well, right at the end of that, I guess, we're going to want to return our codons list so that it now returns a list of codons. So let's just confirm that what's happening here. Generate codons, cat gdc aaa. Oops, let's run that. Okay, cool. You see we're getting a list back now, right? So previously we were just printing these things out. Now we've actually got a list, excuse me, with these 3 distinct codons. Okay, so now if we want to print these, we can always print this, right? But if we just wanted to know the codons to do other sort of logic on them, we now have this list of codons. And this is a much, much better approach to programming. Okay, modify the print codons function so that the parameter is now a list containing the codons. Print each codon found in the list on a separate line. Okay, well now we want to print these codons. So we're going to take a list of codons, and we have a list, right? So if we want to print each thing in the list on a different line, we're going to want multiple print statements. And if we just want to print for every element in the list, then we can use a for in loop again. Okay, so for each codon in codons. Okay, now similarly, when the list stepped through the string, sorry, when our for loop stepped through the string up here and looked at every individual character in the string, if we for in loop over a list, this codon guy here is going to become each element in the list. Okay, so for every codon, right, we just want to print it. That's all we wanted to do before. So if we use our generate codons, I'm actually going to store this now in something called codons. Okay, let's just check what's in there. So these 3 guys, okay. So now if we go print codons and give it our codons list, we can see it's gone and printed out our 3 letters this time. This is a much, much better way of sort of structuring this problem, right? Because later down the track, if we want to do something else with these codons, we've already built a function that can split it up into codons for us. Okay, now there are other ways of doing this. I could have done this guy with a for loop, for instance. So if I wanted to do this with a for loop instead of a while loop, okay, let's just sort of split this guy up a bit. So this is one approach. It's a perfectly valid approach. The other approach we can do is with the for loop. Now remember, when we looped over sort of numbers before, we were using the range command. Okay, now we don't necessarily just want to loop over the length of the DNA, right? Because that'll give us an object that counts 0, 1, 2, 3, 4, all the way up to the end of the length of DNA, right? But whereas in here we're counting in 3s, and that's kind of what we want to keep doing with our range. Okay, So range can actually take, same as the slice sort of notation we were using before this guy, range can actually take three things. It can take a start, or it can take one thing, in which case it counts from 0 up into len DNA. Okay, so if I have for I in range 10, print I, right? We can see it prints from 0 to 10. Or if I go for I in range 5, 10, oops, then we can print from the numbers from 5 up to but not including 10. Okay, and finally, we can actually give it a third guy, which exactly the same as the slice is a stepper. So if I say I want to count from 5 up to but not including 10 and counts to 2, right? Python's happy to do that for us as well. So in this case, we wanted to count starting at 0 up to DNA. So we wanted to count it from 0 up to DNA, but we also wanted to do it in counts of 3. Okay, and from there, this loop is exactly the same as our while loop, right? So all we have to do is append the same thing we were using before, I to I plus 3. Okay, and then this for in range loop is actually doing the exact same thing as this while I with the plus 3 here. Okay, so this one's a bit easier to understand, but if you can get into the habit of using range and understanding how range works, this one's it's a lot cleaner, right? It's one line, and then we don't have to worry about this loose variable I and keeping track of it. Whoops, what have I done? I've left out a square bracket. Let's run that. So generate codons. And there, see, it's doing the exact same thing. Okay, so there's two solutions for this problem. And separating the printing down here. Let's get some water. Okay, we've got down here now, number extraction. Data mining is the process, yada, 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 yada. Write a function getNumber string, which returns the first positive integer in the string, or none if there are no integers in the string. Okay, so this is a pretty cool problem. Probably something that's going to be useful in the future. So getNumber string. So let's just have a look at some of the examples here. It's getting the first positive integer in the string. So we can see we got a 22 out here because we hit this 22 here. Okay, here we got a 14 because I suppose our first number was there. Okay, and here we got nothing because there's no numbers. Okay, cool. You may find it useful to use the stir.isDigit method. Okay, now let's say I've never heard of the stir.isDigit method. Oh, whoops, accidentally ran that. Didn't mean to do that, just wanted to get back to the shell. So let's say I've never heard of this stir.isDigit method. What is it, isDigit? Okay, well it's a method of the strings, right? But if I wanted to know how to use it, I can actually use the Python inbuilt help. Stir.isDigit. Help on method descriptor isDigit. Returns true if all characters in S are digits, and if there is at least one character in S, false otherwise. Oh, okay, sorry, return true if all characters in digits, and all characters in S are digits and there is at least one character. Okay, so if we give it a blank string, and we go isDigit, it should give us a false, I guess is what that's saying. Okay, cool. So I guess essentially we can check if 2 is a digit, true, and we can check if balls is a digit, false. Okay, and big number, true. Okay, cool. Well, that's going to be pretty useful here, right? So I suppose what we want to do here is loop over each of these characters and somehow sort of find where our numbers are. Okay, so I guess let's get started with that. For C in string. Now, let's just have a bit of think about how we're going to do this. We're definitely going to need some sort of check on the isDigit, right? So we're going to have to check if C is digit, then we're probably going to want to do something here, right? So, you know, we have a number, else we have a letter. Or we have a non-number. I suppose it could be a dot or something. Okay. Now, in terms of how this isDigit works and the shell over here, we can see that it says stir.isDigit, right? That doesn't mean you sort of call it this way. It's referring more to that it belongs to the string class, okay? So if something is a method like this, it means we can give it any string, okay? So I can give it the string happy. And we can call .isDigit. and run from there. Okay. Now it is possible to call it using the stir method, but we have to use it a bit differently. Stir.isDigit 3. And that also works the same as if we were to have 3.isDigit. Okay, so that's just all how that notation working. This just means that this guy is built to work on strings. Okay, so let's have a bit of a think here. If we go through our character and we find a digit, well, that doesn't necessarily mean we can exit early, right? We can't just be like, oh, cool, return C, C is our number. Because what if there's two numbers in a row, like here, right? We need to sort of think about all the numbers that we get, so in this case the 2 and the 2, and then we need to know when to stop reporting numbers. So I'm gonna start off here with a number guy. Now we're dealing with strings, right? So my number guy is going to start off as a blank string, and every time we find a digit, we would want to build up that string. Okay, so similar to when we were doing the appending of the other characters, I guess I want to add C to my number. Okay, else we have a non-number. So let's just say else here. We're going to do nothing for the moment, and then let's just see how our number guy goes. Okay, so I'm actually going to copy one of these guys, and let's run our shell here. So get number, and then all this stuff, and 221719. Okay, so we can see that it's only getting the digits, so that's working. But we wanted to stop here, right? So we're gonna have to think a bit more carefully about what to do when we have a non-number. Okay, so well, let's think about this. If we find a non-number, we also can't just exit, right? Because this Z, we would just see this Z and we would be done, right? So we can't just exit here. We gotta think a bit more carefully. So essentially, I guess we want to keep looking at characters regardless of what they are, up until we find a number, right? At this point, once we've found a number, we then need to think, well, how do I know when I'm done? And only then, when we find a non-sort of number, then can we exit, okay? So we're definitely gonna need some sort of elif here, right? Because that was a lot of sort of reasoning I just did there. So I guess our sort of condition we want here is elif if we've already found a number, okay, so if we've already found a number, and then we find something that's not a number, okay, so we're in the elif, right? So if it wasn't a digit and we've already found a number, then I suppose at this point here we're done, right? We've found the end of our string, so we would call it a day, okay. So if we've already found a number, well, how would we know if we'd already found a number? There's a couple approaches you could use here, right? We could always have some sort of variable that we set. For instance, we could have something that's like, found a number, and we could set that to be false. And then the moment we find a number in here, we could go found a number and make that guy true. Right? And then this line here, if we've already found a number, well, that becomes pretty easy. We just check elif found a number. Okay? Smart variable names make code very easy to read, guys. Okay? So, if we haven't found a number, no. And then if we find something that is a number, we say, yes, we have found a number. Then we keep looping until we find something that was not a number. And then if we'd already found something, we are done, right? So I guess at this point here, we would break our loop, and then print out our number here, and let's see what's happening. So let's actually try that approach. Let's see how that goes. Oh, sweet. Well, there's our 22. Okay. Now, this isn't the most efficient way, right? Like, for instance, we've got this else out the bottom here that does nothing. So let's just entirely get rid of that, right? And I guess we're not returning our number yet. So this statement here would technically be a return. Okay. But if we have a bit more of a think about it, this is really where our logic ends, right? So there's no reason why we can't return our number here. Okay, this is where we want to return our number. We also don't really need this found a number guy, okay, because something else we have, we wanted this check to be like, have we found a number? Now, if we've found a number, what do we do when we find a number? We add them to this guy, okay? So realistically, if our number guy is an empty string, we know we haven't found a number. And if our number guy contains numbers, then we have found a number, okay? So if we go elif found a number, then what can we do? Well, elif, I suppose what we could check is if the length of number is greater than 0, right? And that means we've added characters to number, okay? Or even easier than that is if we actually just write if number. Python is smart enough that when we check yes or no for a string, right? Purely by putting a string there, Python basically goes, well, if there's no characters, because it tries to convert it into a true or false, right? If we give it an empty string, Python tells us false. If we give it anything that has characters in it, Python tells us true. So we can actually just go elif number, and that means, well, number has characters in it if we get a true hit there, right? In which case we are done and we can just return our number. So we don't actually need this found a number guy, right? That is certainly one way of doing it, but we don't really need it, okay? Now, since we're returning number inside here, the only way we're going to get out the bottom is if we never found the number, right? Or the end of a number. So I suppose in this case, we could return none, right? And be done and say, well, there were no numbers. So let's quickly check if that's got any problems. Get number, ZZ23. There's our 3, 4, 5. Okay. But what if I do something like this? We're getting nothing back, right? Because we've managed to fall out the bottom of our loop. Okay. So I guess before we can return none here, we would have to quickly check first if we have number. Okay, or I suppose an easier way is if we have number, we would want to return number. Okay, now that's a bit sort of duplicated of having here, so we could have a break here, but this is really just a sort of final check, you know, in case the last character was a number. Because if the last character was a number, then we won't see it when we come out the bottom of this loop, right? And then we'll just hit the return num. So we would first want to check for number. Let's just reload that. Get number. And there we can see now we're getting our number 222. It's still working for all the other cases. Okay? So you got to be careful about these edge cases when you write these programs, right? Because there's several cases here, right? There's the really obvious case where we have, a bunch of letters and then a number and then a bunch of letters. But, maybe we have some numbers here that we need to check for. Or maybe it starts with numbers, right? You always got to consider the cases when you do your testing at the end. Otherwise, you might not even know if your function entirely works. So let's just think about this. One last thing here. Challenge negative numbers. Modify this function to also handle negatives. Okay, so that's a bit more tricky. Because we could have a whole bunch of negatives, right? What if we actually try and... Where's my shell gone? What if we actually, had a number that was like this, for instance? We can't just be adding on all the negatives to our string because that's going to sort of panic at the end when Python gets it. And I've actually just realized that our getNumber function is returning a string. Look at that. Quote 222. Bad on me. This should definitely be returning an integer. So we need to cast this guy to an integer before we return it. Because, if we've done our function right, it should definitely be all numbers, right? Int get number. There we go. The actual number 22. So that works a lot better. Cool, much better. Now, we need to consider this negative case, right? So I guess the easiest thing to do would be to keep the exact same function, but all we really need to do is think about if our number had a negative sign at the start, okay? Because I guess we don't really care if it's a million negative signs and then 345, right? All we really care about is this guy. So we need to be keeping track of the character before the character we had, right? Because if I hit this 3 and I start counting numbers, I want to know what this guy was. Okay? So I'm going to set up another variable here, previous. And every single time, I want previous to be whatever the previous number was. So I suppose once I get to the end of this loop here, we should set previous to be C. Okay, so that means every time we go through the loop, you know, the first letter is, say, a 3, or you know, a Z or an A or something. We get through here, we finish all that stuff, and then we've set previous to be that letter. So the next time we go through the loop, we'll have previous. Okay? Now, elif number. So if it wasn't a digit, if the number we're looking at isn't a digit, we don't really care what previous is, right? The only time we care what previous is if we start counting numbers. And then we want to know if it was a negative. So I suppose if we hit a number, right, we have a number here, you know, but is it negative? Oops. But is it negative? So I suppose we can do a quick check here, right? If our character before it was a negative sign. Okay? Now what do we want to do? If our character before it was a negative sign, then, well, we just want to append the negative sign at the start, right? So I guess before we even add this number plus C, we can add a negative sign to the start of our character. In fact, we can actually just make this a straighter sign, right? Because it's going to be the first minus sign, right? Because if we encountered multiple numbers first, then we would exit here. But if this is the very first number we're encountering, and we need to know if we can put a minus sign in front, right? So we should just check, well, was the character before it a minus sign? And let's go from there, actually. So let's get rid of that guy. Try running that. I'm actually going to... Oops, what have I forgotten? Oh, double equal sign. Rookie error. I'm going to put this shell over to the side quickly just so I can see these examples. Get number... Where's my shell gun? There we are. Negative 39. Cool, cool, cool. Let's check this one. So we've got a bunch of dashes before, but not directly before, so that should be fine. Yep, 23. Cool. And I'm actually going to chuck in... I'm going to put in a whole bunch of negatives here. Let's just see if it works for the case I thought about. Negative 33, right? We don't care about any of these before. Okay, sweet. So there we have it, guys. There is our negative number checker as well. I really encourage you guys, if you've had a good go at the sort of base ones, like this number extraction, and you think you know how it's working, you got yourself a working solution, definitely have a go at these challenge numbers, right? Even if you can't get them out. Some of them are quite difficult, right? But even if you can't get them out, it still gets you thinking about the best way to do these things. Okay, so I guess that's it for this tute. As always, if you got any questions, chuck them in the comment section below, chuck them on the forums on Piazza. And yeah, otherwise, I guess I will catch you guys next week in the next video.